Hey, Wildcats. Today we're looking at Thursday, November 8th, radical function transformations on page 32. If you would, update your table of contents. All right, now your table of contents is updated. Let's take a look at our notes. Radical function transformations on page 29. So when f of x equals negative a, the root of negative bx minus h plus k when n is greater than 0. So the negative in front of the a reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When negative is inside, it reflects over the y-axis. When b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. If it's plus h, it translates left. Minus h, it translates right. Plus k translates up. Minus k translates down. It would update your notes. All right, now your notes are updated. Let's take a look at the examples. All right. So first things first, we're going to graph x to the 1/2 power. Let's lighten it up a little bit. But let's write this as x to the 1/2 power is the same as the square root of x to the first power. And in simple terms, you can just write it as the square root of x. So to graph this, let's let x equal 0. So that's the square root of 0 equals 0. So your first point is 0, 0. Then 1, the square root of 1 equals 1. So 1, 1. The square root of 4 is 2. So 1, 2, 3, 4, 2. And then 9. So the square root of 9 is 3. So 9, 1, 2, 3. Okay. Now domain is bracket 0 to infinity. The range is bracket 0 to infinity. All right. This is the same as the square root function. All right, now we're actually going to go in a little different order. We're going to do example 3, and 5 first. All right, now you'll notice the reason why we did example 1 is because this is the parent function of example 3 and example 5. So we're going to use those points as a direction. So first things first, we move our vertex. So that -4 means we go down 1, 2, 3, 4. There's a new vertex. Okay, and I need to adjust this line. You'll see why in a minute. All right, so we know our directions are HK, 1, 1, 4, 2, 9, 3. And that's based on the parent function. Okay. But here, I noticed that we need to multiply those by 2. So that's times 2. So that equals 2, 4, 6. So those are our new directions. So from here, we go right 1, up 2. Here we go right 4, 1, 2, 3, 4, up 1, 2, 3, 4. And then right 9, up 1, 2, 3, 4, 5, 6. Domain, bracket 0 to infinity. Range, it looks like bracket -1, 2, 3, 4, -4 to infinity. So the two transformations, you have a vertical stretch of 2 and it's down 4 units. Okay, so finish up example 3. All right, now let's take a look at example 5. Okay, so here, and I need to move this line as well. Okay, so let's move the vertex. So this means we go right 2, up 1, 2, 3. So there's a new vertex. We graph by direction, so we know that's H, K, 1, 1, 4, 2, 9, 3. This says we need to multiply everything by -1, or the y values by -1. So that's -1, -2, -3. So from this point, we go right 1, down 1. We go right 1, 2, 3, 4, down 2, and then right 1, 2, 3, 4, 5, 6, 7, 8, 9, down 1, 2, 3. Your point's approximately there. Our domain looks like it's bracket +2 to infinity, and our range is -infinity to +3 bracket. All right, so the transformations we have reflect x-axis. We have right 2 units. And then we have up 3 units. All right, so if you would finish up example 5. All right, now that was all square root transformations. Now let's look at cube root transformations. So we start here, and we know that x to the 1/3 is equivalent to cube root of x to the first, which is just the same as cube root of x. So I guess I could write that here, and I can write this here. So let's start with -8. The cube root of -8 is -2, -1. The cube root of -1 is -1. The cube root of 0 equals 0. Cube root of 1 is 1, and cube root of 8 equals 2. So let's go ahead and graph those points. So -8, 1, 2, 3, 4, 5, 6, 7, 8, down 2. -1, -1, 0, 0, 1, 1, and 10, 9, 8, 1, 2. This is the cube root parent function. So real simple, domain is -infinity to +infinity, and range is -infinity to +infinity. This is the same as the cube root function. Now, example 4 and 6's transformation is going to be based on this parent function. All right, example 4. So we first move the vertex. That +3 means we go left 3, so 1, 2, 3. And then we graph by direction, which we know is -8, -2, -1, -1, h, k, 1, 1, 8, 2. So we go left 1, 2, 3, 4, 5, 6, 7, 8, down 2. It's about right there. Then left 1, down 1, right 1, up 1, then right 1, 2, 3, 4, 5, 6, 7, 8, up 2. Real simple, cube roots, domain, range are always -infinity to +infinity. And then we only have one transformation, that's left 3 units. All right, let's take a look at example 6. All right, so first thing first, we need to move the vertex. So we go right 1, 2, 3, up 1. And we graph by direction, which we know are And I'm just going to use -8, -2, HK, and 8, 2. And the reason why I'm only using those numbers is because I have to divide them by 2. So that's -1, +1. Okay. So from here we go left 1, 2, 3, 4, 5, 6, 7, 8, down 1. And then we go to the right 1, 2, 3, 4, 5, 6, 7, 8, up 1. And we know our curve goes like this, and then it curves kind of like S up to there and here. Now we know domain's real simple, -infinity to +infinity. Range is -infinity to +infinity. And a few transformations. We have vertical compression of 1/2. We have right 3 units. And we have up 1 unit. All right, so if you would, finish up the examples and start working on the assignment and have a wonderful Wildcat day.